For example 2 of higher order derivatives, we have y cubed minus 3x squared, y cubed minus 3x cubed equals 6. Find d squared y dx squared. So find the second derivative. This one's going to be more involved because it's an implicit formula. It's an implicit equation, and so we're going to have to use some implicit differentiation on top of the fact that we have to take the derivative twice. So let's go ahead and get to this. We're going to find the first derivative by taking the derivative to each of these. We will have to apply implicit. Derivative of y cubed is 3y squared dy dx minus, move the 3 down here, so it would be 9, then subtract 1 from the exponent, x squared equals 0. And of course, to find the first derivative, we now have to get dy dx by itself. And so we will add 9x squared to both sides. Sometimes I don't show everything. When you get up in upper level calculus, sometimes you run out of time, but there we go. That's what we're doing there. Okay, and then we end up with 9x squared over here. Now we just want to divide both sides by 3y squared, and we'll get this. And of course, 9 over 3 simplifies to 3 on top. So our first derivative, dy dx, equals 3x squared y over y squared. But we want to find the second derivative. We have to take the derivative of this again, and we can already see it is a fraction, so we'll be using the quotient rule. And again, taking the derivative of the first derivative gives you the second derivative, which is what this problem is asking. So because we're using the quotient rule, I'm going to label the top f and the bottom g. We know it's f prime g minus ft prime over g squared. So f prime would be 6x, g prime would be 2y times dy dx, because we have to use implicit, and then we can see that g squared is going to be y to the fourth. So let's write out our quotient rule, which we'll use to find the second derivative. We'll plug all that stuff in, f prime g minus ft prime over g squared. At this point you might be thinking, okay, well our second derivative equation involves the first derivative. Is that okay? The answer is no, okay? We need to plug in what we found out to be dy dx, which we have an equation for. That's where the first derivative comes into play. So when you're finding the second derivative, you're going to have, and it's implicit, you're going to have to plug in what you found the first derivative to be. Okay? So first of all, let's go ahead and simplify this. This is going to be 6xy squared. We'll turn to minus 6x squared y dy dx. In the bottom, I'm not going to simplify anything. I'm just going to leave it being squared. We need to replace this and substitute it. So what did we find dy dx to be? What was the first derivative? Let's go back and take a look. If you recall, we found dy dx to be 3x squared over y squared, our first derivative. So we're going to replace that in our second derivative equation and simplify. So what we will do is every time there's a dy dx, we will replace with 3x squared over y squared. That's all we're doing here is just substitution in those two expressions, and then we're just going to simplify that. Okay, let's take a look. So first of all, we can see that this 6 and 3 becomes 18. All right, and then this x squared and this x squared becomes x to the fourth. And also, we'll just have a y on the bottom. So there's that simplification. Minus 18x to the fourth over y. Okay, and then down here at the bottom, these y's will cancel, and we'll be left with 6x squared on top and y on the bottom. Don't forget it's being squared. Okay, and then of course we do want to square it, so we have to square everything inside. It will become 36x to the fourth over y squared on the bottom. Now we want to get rid of a fraction on top and the fraction on the bottom, so we will level that out by multiplying by y squared on the bottom and y squared on the top. It will cancel the y squared here, and it will change some things on top and get rid of this y as well. So that's what we're going to do. It's going to cancel the y squareds down here. This will become 6xy to the fourth, and then when we distribute into this one, it's going to cancel the y on the bottom but leave an extra y on top, hence minus 18x to the fourth y. Now if you notice, there's a GCF between all of these three terms left, and it would be 6x. So I'm going to pull out a 6x on top, therefore I can cancel some stuff on the bottom. So there I am pulling my 6x out and left with y to the fourth minus 3x cubed y. Pulling it out from there. Didn't do anything to the bottom, but the 6x and the 36x to the fourth will leave me with a 6x cubed on the bottom. And this is my final answer once I've simplified d squared y. Dx squared is equal to nothing more than y to the fourth minus 3x cubed y over 6x cubed. Actually ends up being pretty simple once we plug some stuff in. So here's our final answer, and I will go back and show you what we started with just so we can see where we came from. Alright, so here's where we started, and that's what we ended up with. A pretty simple second derivative. If you have any other questions about implicit differentiation and second derivatives or even higher order derivatives, let me know.